So to simplify this, what we're going to want to do is multiply. The trick for this one is what's called clearing the fraction, and it kind of takes care of the same thing. Notice that the denominator is the same for the top and the bottom. So to clear that, all you really have to do is multiply by root 5 on the top and the bottom. And that's something you just recognize. You don't have to multiply by the conjugate of this bottom thing. It's overkill to do that. You can, but it's overkill. It's simpler if you just multiply by root 5 over root 5. So when I do that, make sure you distribute it, right? Because it's kind of like this. Does that make sense? So your answer would be 8 root 5 minus 1 over 16 root 5 plus 1. And now I can multiply by the conjugate. You could have, like I said, originally you could have multiplied by the conjugate. I guess I shouldn't have called it overkill. It would have still worked. But a lot of times when you do that, you can see right away how something cleans up and you don't have to mess with it. But it doesn't happen to clean it. Like if this happened to be root 5 right here, then you wouldn't have to do any more. You'd be done. Because root 5 times root 5 would have just been 5, and then you'd have a rational denominator. Does that make sense? But we do have to do more for this because the denominator still isn't rational. So I'm going to multiply by the conjugate, which is 16 root 5 minus 1. And when I do that, I will get, I'm going to keep the numerator. I'm just not going to touch it yet. I'm just going to take a look at the denominator and make sure that looks good. So it's going to be 16 squared times 5 minus 1. Because the middle terms are going to cancel out because it's the conjugate. So 16 squared is 256.
I think so.
256 times 5. Okay, which is 1,280.
No, you can't have any.
Another way you could do this, if you can't use the calculator, you can go 16 times 16 times 5 and break this 16 into 2 times 8 so that the 2 and the 5 make 10.
Oh. And
that would be a little bit easier. So then you're really just doing 16, you can break 16 into 8 times 2. So this is really 64, right, times 2, which is 128, times 10, which is 280. So you could actually have done that if you just break the number up. You can do that in your head. So that's really 1280. Is that what we said it was? 1280 minus 1 is 1279. So that's the bottom. And the top is going to be, now I'm going to FOIL that out. So 16 times 8, like we talked about before, that's 8 times 2, which is 128. 128 times 5, 128, no, let me do it the other way. 8 times 16 times 5. The best way to multiply 8 times 16 times 5 is to break this up into 8 and 2, to break that into 10, and take those as 64. Got it? So it's 640. See how I'm doing like mental math that way? And then this and this are going to be negative 16 root 5 and
1
and negative 8 root 5. So it's negative 24 root 5. And then we just have a positive 1. So it equals 641 minus 24 root 5 all over 1279. Let's see if it would have been easier doing it the other way. So I'm going to leave this answer here, and let's just see if it would have been easier. I'm just curious to see if it would have been easier if we would have gone straight to multiplying by the conjugate. So that would be 16 minus 1 over root 5, 16 minus 1 over root 5, and foiling these two out on the bottom would just get us 16 squared, which is 256, minus 1/5. Right?
Yeah.
And then on the top, foiling them out would get us, what's 16 times 64 times 2 is 128, right? 128 minus 16 over root 5, and then minus 8 over root 5, so that's minus 24 over root 5, and then plus 1/5. See, to me, that's still a mess.
Yeah, me too.
Because now I have to deal with the fractions. So I think my first way was better. You always want to try to eliminate fractions if you can. In a compound fraction, in general, you want to eliminate fractions if you can. Just seems like it'd be a lot easier. I don't even want to continue doing that. So use that method I showed you at first.